You are tuned to Iri-e-learning and I am your host, Teacher. In this structure and bonding lesson, we will practice writing balanced chemical equations. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to balance different chemical equations. It's practice time. You have 5 seconds to balance each equation. If you need more time, pause the video before the music stops. After completing the task, you can continue playing the video to check your answer. Question 1. Balance the following chemical equation for the combustion reaction involving hydrogen gas as it reacts with oxygen gas to produce water in the form of steam, which is water in the gas state. Also, here is an interesting fact about water. Water is the trivial name of the compound, while its chemical name is hydrogen oxide. Let us begin by ensuring that the atoms that exist on the reactant side are also present on the product side. So on the reactant side, we have hydrogen and oxygen. On the product side, we also have hydrogen and oxygen. Our second check is to ensure that the number of each type of atom present on the reactant side is equal to their counterpart on the product side of the equation. On the reactant side, there are 2 hydrogen atoms, 2 oxygen atoms, and on the product side, there are 2 hydrogen atoms and 1 oxygen atom. The number of hydrogen atoms on both sides of the equation is equal. However, the oxygen atoms are not. On the left side, there are 2 oxygen atoms, while on the right side of the equation, there is 1 oxygen atom. So we need to find the LCM of 2 and 1, which is 2. Therefore, we need to increase the number of oxygen atoms on both sides of the equation to the value of the LCM, which is 2. There are already 2 oxygen atoms on the reactant side of the equation, so we move to the 1 oxygen atom on the product side of the equation. What multiplier would increase 1 oxygen atom to 2, and that would be 2. So 2 is written in front of the formula for water because the oxygen atom is in the chemical formula for water. So now we have 2 times 1 oxygen atom giving 2 oxygen atoms. The multiplier also affects the number of hydrogen atoms in the formula. For now we have 2 times 2 hydrogen atoms, which gives 4 hydrogen atoms. So now the number of oxygen atoms are equal on both sides, but the number of hydrogen atoms are no longer equal. We have 2 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side. The LCM of 2 and 4 is 4. So we need to bring the number of hydrogen atoms up to the value of the LCM, which is 4. You notice that the number of hydrogen atoms on the product side is already equal to the LCM. So we tackle the number of hydrogen atoms on the reactant side. What multiplier would increase 2 to 4, and that would be 2. 2 times 2 hydrogen atoms would give us 4 hydrogen atoms. So the multiplier is placed in front of the chemical formula for the hydrogen molecule. And as a result, we have 2 times 2 hydrogen atoms giving us 4 hydrogen atoms. As you can see, all the atoms on the reactant side is now equal to their counterpart on the product side. This equation is now balanced. And as you can see, we have removed all the calculation bit. Please note you can do that on a rough sheet of paper when you're doing your calculation, but this is all we require for the balanced chemical equation, showing where the multipliers are written in front of the various chemical formulae. So the balanced equation states that 2 molecules of hydrogen gas will react with 1 molecule of oxygen gas to produce 2 molecules of water in the gaseous state. Question 2. Balance the synthesis, also known as a combination reaction, in which aluminium solid reacts with chlorine gas to produce aluminium chloride solid. We begin by ensuring that the atoms that exist on the reactant side of the equation are identical to those on the product side of the equation. We have aluminium on both sides as well as the chlorine atoms on both sides. So our first check is okay. The second check is to ensure that the number of atoms on both sides of the equation are balanced or are equal. If not, then we have to balance the numbers by using the appropriate multiplier. So starting with the reactant side, we have one aluminium atom and two chlorine atoms. And on the product side, we have one aluminium atom and three chlorine atoms. You will notice that the number of aluminium atoms are currently equal. However, the number of chlorine atoms are not. There are two chlorine atoms on the reactant side and three on the product side. So we find the LCM of 2 and 3, and that is 6. This means we have to increase the value of each count of chlorine up to the value of 6, which is the value of the LCM. So what multiplier would increase two chlorine atoms up to 6? And that would be 3, because 3 times 2 would give us 6. So we insert the multiplier in front of the formula for chlorine, or in front of the formula containing the chlorine atoms. Now we have 3 times 2 chlorine atoms, which gives us 6 chlorine atoms. So on the product side, there are 3 chlorine atoms. What multiplier would increase 3 to 6 chlorine atoms? And that would be 2. So 2 times 3 we know would give us the 6. As a result, we put the multiplier in front of the formula of the compound that contains the chlorine atoms. And so now we have 2 times 3 chlorine atoms, which gives 6 chlorine atoms. The multiplier also changes the number of aluminium atoms in the compound. So now we have 2 times 1 aluminium, which gives 2 aluminium atoms. So now the number of chlorine atoms are balanced, but the number of aluminium atoms are now unequal on either side of the equation. We have 1 aluminium atom on the reactant side and 2 aluminium atoms on the product side. So the LCM of 1 and 2 is 2 for aluminium. The number of aluminium atoms on the product side is already equal to the LCM, so we move to the 1 aluminium atom on the reactant side. So what multiplier would increase 1 aluminium atom to 2 aluminium atoms? And that would be 2. So we insert or write the multiplier 2 in front of the chemical formula that contains the aluminium atom. So now we have 2 times 1 aluminium atom, which gives 2 aluminium atoms. All the atoms on the reactant side are now equal to their counterparts on the product side. So this equation is balanced. And the balanced equation states that 2 aluminium atoms in the solid state will react with 3 molecules of chlorine gas to produce 2 molecules of aluminium chloride in the solid state. Here we have another synthesis reaction or combination reaction in which nitrogen gas reacts with hydrogen gas to produce ammonia gas. As we can see in this reaction, there are reversible arrows. Don't be alarmed by the reversible arrows. We balance the equation just as we have been doing with all the other examples. So first we check to ensure that the type of atoms on the product side are identical to those on the reactant side. We have nitrogen atoms, we have nitrogen atoms. We have hydrogen atoms, we have hydrogen atoms. So the check for the type of atoms on each side of the equation is complete. Next, we check to see if the number of each type of atom is identical or the same on both sides of the equation. If not, we need to balance the equations by introducing the appropriate multiplier. So on the reactant side, we have 2 nitrogen atoms, 2 hydrogen atoms, and on the product side, we have 1 nitrogen atom and 3 hydrogen atoms. None of the atoms on the reactant side are equal to their counterpart on the product side. Let us start with nitrogen since it is the first in the equation. So we have 2 nitrogens on the reactant side, 1 on the product side. The LCM of 2 and 1 is 2 for nitrogen. So the number of nitrogen atoms on the reactant side is already equal to the LCM, so we need to increase the nitrogen atom on the product side to 2. So what multiplier would increase 1 to 2? And that would be 2. So we put the multiplier in front of the formula that contains the nitrogen atom. So now we have 2 times 1 nitrogen, which gives 2 nitrogen atoms. The multiplier also changes the number of hydrogen atoms. So now we have 2 times 3 hydrogen atoms, which gives 6 hydrogen atoms. The number of nitrogen atoms is balanced on both sides of the equation. There are 2 nitrogen atoms, but the number of hydrogen atoms are still unequal. So we have 2 hydrogen atoms on the reactant side and 6 hydrogen atoms on the product side. The LCM of 2 and 6 is 6. So the number of hydrogen atoms on the product side is already equal to the LCM. So we need to increase the number of hydrogen atoms on the reactant side from 2 to 6. And the multiplier that would do that is 3. So we put the multiplier in front of the formula that has the hydrogen atoms. Now we have 3 times 2 hydrogen atoms, which gives 6 hydrogen atoms. All the different atoms on the reactant side are now equal to their counterparts on the product side. This equation is balanced. So the balanced equation is telling us that 1 molecule of nitrogen gas will react with 3 molecules of hydrogen gas to produce 2 molecules of ammonia gas. For question 4, we're going to write a balanced chemical equation for the following decomposition reaction in which sodium hydroxide solid is heated and decomposed to sodium oxide solid and water in the gas state. First check is that the atoms that exist on the reactant side also exist on the product side. There is sodium, oxygen, and hydrogen on the reactant side. There is also sodium, oxygen, and hydrogen that exist on the product side of the equation. So our first check is complete. The second check is to see if the number of each type of atom is equal on both sides of the equation. So on the reactant side, we have 1 sodium, 1 oxygen, 1 hydrogen. On the product side, we have 2 sodium atoms, 2 oxygen atoms, and 2 hydrogen atoms. None of the atoms on the reactant side is equal to their counterpart on the product side. So we're going to start with balancing the sodium atom, seeing it's the first atom in our series. So there is 1 sodium on the reactant side, but 2 on the product side. So the LCM for 1 and 2 is 2. Notice that the number of sodium atoms on the product side is already equal to the LCM of 2. Therefore, we move to the sodium atom on the reactant side, where there's 1 sodium atom. So what multiplier would increase 1 to 2 sodium atoms? And that would be 2. So we write the multiplier in front of the chemical formula in which the sodium atom exists. Now we have 2 times 1 sodium atom, which gives 2 sodium atoms. The multiplier of 2 also affects the number of oxygen and hydrogen atoms within the formula. Therefore, 2 times 1 oxygen atom would give 2 oxygen atoms, as well as 2 times 1 hydrogen atom gives 2 hydrogen atoms. All the atoms on the reactant side of the equation are now equal to their counterparts on the product side of the equation. This equation is now balanced. The balanced equation states that 2 molecules of sodium hydroxide solid will decompose to give 1 molecule of sodium oxide solid and 1 molecule of water vapor. Question 5 involves balancing a double displacement reaction in which an aqueous solution of iron 2 chloride reacts with an aqueous solution of sodium hydroxide to produce iron 2 hydroxide solid, also known as a precipitate, and an aqueous solution of sodium chloride. And for emphasis, note that when 2 ionic solutions react and a solid is formed, that solid is called a precipitate. First, we check to ensure that the different types of atoms that exist on the reactant side of the equation are the only atoms that exist on the product side of the equation. The reactant side contains iron, chlorine, sodium, oxygen, and hydrogen. On the product side, we have iron, chlorine, sodium, oxygen, and hydrogen as well. Therefore, our first check is complete. For the second check, we will balance the number of atoms of each element on either side of the equation. So we are going to do our atom count. We have 1 iron atom, 2 chlorine atoms, 1 sodium atom, 1 oxygen atom, and 1 hydrogen atom on the reactant side of the equation. On the product side, we have 1 iron atom. Note that anything that is within the bracket is multiplied by the number outside the bracket, subscript number here too. So 1 oxygen times 2 gives 2 oxygen atoms and 2 hydrogen atoms. There's also 1 sodium atom and 1 chlorine atom. As we can see, the number of iron and sodium atoms on the reactant side of the equation are equal to their counterparts on the product side. All the other atoms need to be balanced. So we'll start with balancing the chlorine atom. There are 2 chlorine atoms on the reactant side, but only 1 on the product side. So the LCM for chlorine is 2. The number of chlorine atoms on the reactant side is already equal to the LCM, so we move to the 1 chlorine atom on the product side. The multiplier that would increase 1 chlorine atom to 2 chlorine atoms would be 2, so we put 2 in front of the chemical formula that contains the chlorine atom. As a result, we have 2 times 1 sodium atom to give 2 sodium atoms and 2 times 1 chlorine atom to give 2 chlorine atoms. So note that the number of sodium atoms on the product side has changed to 2, and there's only 1 sodium atom on the reactant side. So the LCM for 2 and 1 is 2. As a result, the sodium atoms on the product side is already equal to the LCM, so we need to increase the sodium atoms on the reactant side to 2. And that multiplier would also be 2. And so we now have 2 times 1 sodium atom to give 2 sodium atoms, and 2 times 1 oxygen atom to give 2 oxygen atoms, as well as 2 times 1 hydrogen atom giving 2 hydrogen atoms. As a result, all the atoms on the reactant side are now equal to their counterpart on the product side. So the balanced equation states that 1 molecule of iron 2 chloride in the aqueous state will react with 2 molecules of sodium hydroxide in the aqueous state to produce 1 molecule of iron 2 hydroxide in the solid state and 2 molecules of sodium chloride in the aqueous state. Question 6, we are balancing the following equation in which calcium carbonate solid reacts with an aqueous solution of hydrochloric acid to produce an aqueous solution of calcium chloride. Carbon dioxide gas is evolved and water in the liquid state is also formed. So we just make sure that the same atoms occur on both sides of the equation. There is calcium, carbon, oxygen, hydrogen, chlorine. We have calcium, carbon, oxygen, hydrogen, and chlorine. So the same atoms occur on both sides of the equation, so that check is complete. Now we're going to balance the number of atoms on both sides of the equation. So we have 1 calcium atom, 1 carbon atom, 3 oxygen atoms, 1 hydrogen atom, and 1 chlorine atom on the reactant side of the equation. On the product side, we have 1 calcium atom, 2 chlorine atoms, 1 carbon atom, 3 oxygen atoms in total, and 2 hydrogen atoms. We're going to erase the atoms that are already balanced just to see which ones we have to balance. So the calcium atoms are already balanced, the carbon atoms are already balanced, the oxygen atoms are already balanced. So we need to balance the number of hydrogen atoms and the chlorine atoms on both sides of the equation. So we'll start with balancing the number of hydrogen atoms. On the reactant side, there's 1 hydrogen atom. On the product side, there are 2 hydrogen atoms. The LCM between 1 and 2 is 2. Now, the number of hydrogen atoms on the product side is already equal to the LCM, so we need to increase the number of hydrogens on the reactant side to the LCM 2, and that would mean we would need a multiplier of 2. So the multiplier 2 is placed in front of the chemical formula that contains a hydrogen atom. So now we have 2 times 1 hydrogen atom, which would give us 2 hydrogen atoms, as well as the multiplier would change the number of chlorine atoms, 2 times 1 chlorine atom, which gives 2 chlorine atoms. Now the number of atoms on both sides of the equation are balanced. Consequently, the balanced equation states that one molecule of calcium carbonate reacts with two molecules of hydrochloric acid to produce one molecule of calcium chloride, one molecule of carbon dioxide, and one molecule of water. Note, when we get to the unit on mole concept, we will use the more accurate term moles instead of molecules. So we would say 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid to produce 1 mole of calcium chloride, 1 mole of carbon dioxide, and 1 mole of water.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.